Welcome to my channel Physics Guru. In this video, we'll talk about the AC voltage, phase and frequency. AC stands for the alternating current. What does that mean? That means the voltage and the current fluctuates as a function of time. It is not a constant quantity, just like a DC source. It is changing as the time passes by. So how do we represent the changing voltage in terms of equation? This is the one example here. Here the voltage is not a constant because as the time passes by, this quantity does changes. So the voltage is a time function. And if the voltage is changing, so is the current. The voltage and current are not constant, it is fluctuating with respect to the time. So now, let me explain each term in this equation here. If you plot a graph of this voltage, then it would look like this. This is how does it look like. So the Vp, first you see here the voltage is not constant. It increases, then decreases, goes to negative. It does have maximum negative, comes back to 0, goes to the maximum. So it is constantly changing. Now the Vp here in this graph is this one, the maximum voltage. The maximum voltage, or we call as a peak the voltage at any time. So this one is the peak voltage. Here this one will be the negative peak voltage. This would be the negative peak voltage. So in terms of the magnitude, this is the peak voltage here. Okay, that's how it varies. Now coming back to omega. Omega is the angular frequency. What does that mean? How would I imagine the angular frequency? So in order to understand this angular frequency, you have to go a little back and see how is the AC source is produced, or how do we get AC. So let me show you a diagram here. So this is how the typical AC current or AC voltage or AC source is produced here. So we have the two magnets here, north and south, and we have a coil that rotates. Okay, and as the coil is rotating, it does produce an AC source. So this coil rotates at a certain frequency f. If it is rotating at a certain frequency f, then the angular frequency would be 2 pi f. That's how the angular frequency is related with the frequency. So now you might ask me a question, what does this frequency mean? So this frequency is related with the time period. So what does the time period mean now? The time period means how long does it take for this coil to make one complete rotation. So now let's say this side is here, and after a certain time it makes one complete rotation and comes back exactly to this position. And if it takes a time t, then that we call as a time period. So now let's say this coil takes 2 microseconds to make one complete rotation. Then the frequency would be 1 over t, and that is 0.5 times 10 to the 6 hertz. And omega would be 2 pi f, and that we can calculate would be the angular frequency. So this is how the time period, frequency and angular frequency are related. And we'll talk more about this one in another video. So coming back here, so now you understand what the angular frequency is. So this phi is the phase constant. This phi v means the phase constant for the voltage, and phi I means the phase constant for the current. And I'll explain this one in 1 minute. Okay, so the unit, if you look at the unit of the phase, that's the unit is radian. And the unit of omega is radian per second. The unit of frequency is hertz, and the time period is measured in second. Okay, so you might ask a question, why the phase constant is different for the voltage and for the current? The reason is, if you have a capacitor an inductor in a circuit, the voltage and the current are not in the same phase. They could be in different phase, or they could be at a different angle. So the phase in fact will be different for the voltage and current if it contains the other electrical components. Okay, so most of the time the voltage and the current will be in the different phase. All right, so now I'll talk a little about of the phase constant. So what does the phase constant mean? How do you visualize? So that is very straightforward. The phase constant simply tells you how far it is from the origin, or when the signal crosses the origin. For example, I have chosen three waveforms: the blue, yellow, and green. And you can see that the blue one crosses this one is shifted from the x-axis. So that would be the phase constant for the blue voltage here. Okay, so the phase, I can call this one. So this one, if I have to represent, so this one, if I have to represent, so this would be the phase for the blue one, and similarly this one would be the phase for the green one. And now for the yellow one, it is right at the origin, so it has no phase. So phi for the yellow one would be 0. So then if I have to write down the equation, how do I write down the equation here? So for the blue one, Vp, we always write down the Vp, that tells you the peak voltage for the blue one. Sine, we always write down the sine. Omega t, and the phase would be phi b. Okay, and why positive here? The positive is whenever signal crosses to the left of the origin, we always write down the positive. If the signal crosses to the left, for example, the green one crosses to the left, then we always write down to the negative. That's as simple as it is. So remember, when the signal crosses to the left, we write down positive. When the signal crosses to the right, it should be positive. And you also need to understand the different interpretation of this one. So here, if you look at anywhere, doesn't matter, let's say for example here, which one do you see first? You see the blue one. The blue one. So we call the blue voltage VB leads the green voltage by phase. So this one is a leading one. Okay, because you always need a source to compare. So if I compare these two signal, then the blue one leads the yellow one. If I look at these two signal, the yellow leads the green one, or we can say the yellow lags VB. Okay, so this one is the leading one, this one has 0 phase, and this one is the lagging, and this one is a leading. So what does this again mean? This again, leading means it crosses the x-axis first, and this one crosses the x-axis after a certain time. So okay, this one simply tells you which signal crosses the x-axis with a positive slope. Okay, so I hope you understand these things. So in simple words, if I have to write down this equation from the graph, you can always look here. If the blue one crosses to the left, then it has to be positive phase constant. If it crosses to the right, then the phase constant would be negative, and we'll write down as a phi g, negative phi g here. And if it crosses right at the origin, then there is no phase constant, or the phase constant is 0. That's the main things you have to understand in this video. All right, so if you have any questions, write to me, and I will, in the next video, I will give you more examples, the numerical problems about the phase constant, frequency, angular frequency. So that's for today, and if you have not subscribed the channel, do it now. Thank you, and I will see you in the next video. Bye bye.